So it has durability and workflows built in. It has MCP and authentication built in. It has a whole bunch of these things. So we're going to be taking a look at that now.
Hello, everyone. Welcome back to the Open at Microsoft show. I'm here with the CTO of Diagrid, Aaron Schneider. Hey, hello, everyone. Welcome to the show. And we're going to talk about Dapr Agents specifically today. We have videos on the channel on the Open at Microsoft show about Dapr itself. We're going to focus on Dapr Agents and how that can help you to build durable agents. Aaron, quickly, what's Dapr Agents and how that can help the community to do those reliable and durable agents?
Yeah. First of all, thank you for having me. Dapr Agents is essentially geared towards one purpose, and that is to make agents production ready. A lot of people today are taking agents for a spin. They're writing very simple agents. Mostly it's like a single LLM thing. Then they try to create workflows, and that is all well. But when you actually take it into production, you're going to need a whole bunch of extra enterprise features there that are just not apparent in a lot of these agentic frameworks. And it really comes down to workflows and security and reliability and observability, and we'll touch a little bit on those as we talk through more. But Dapr Agents is really geared towards giving you an agentic framework that has all of those important features built into it already. So you don't have to be an expert. You don't need to necessarily know how are distributed systems challenges. You don't need to be an expert or have a PhD on like agentic observability or very sophisticated stateful workflows or writing stateful layers to save your agent memory in some sort of memory layer in the cloud provider you're running on. Dapr Agents should really just allow you to write your agents, have it be as simple as possible, and be made sure that when you take it into production, it's just going to behave correctly.
And that sounds like good news for the community. Then someone watching here that they're not that deep technical, they say, oh, that's too complex for me. That's not true. We're going to show that Dapr Agent could simplify your development cycle or how you're going to build your agents. I'm happy for you to share your screen, and you can.
Yeah.
I'm pretty sure you have beautiful demos there, nice demos that I watched before on your channel as well. And thanks a lot for being this Dapr maintainer for so many years now.
My
For the
pleasure.
community to know that Yoran and Mark Fuzzle, they came from Microsoft and they founded a company called Diagrid, where they focus on this product, this open source. That's a graduated CNCF Cloud Native Compute Foundation project. And let's share your screen. So build the agentic system with Dapr and Dapr agents. That's
Yes.
nice.
So again, we'll be talking today about how Dapr can help you build agentic systems with a pretty big focus on Dapr agents itself specifically. So let's just set the stage a little bit real quick on the current state of agentic adoption. It's early stage. Most of the things you're seeing, even in your organization, I assume, is mostly POCs, demos, mostly running on single machines. If you deploy it, you probably have a dev test single machine thing where you have a Kubernetes cluster, but then you're forced to run single pod because most agentic frameworks cannot be scaled out if you have stateful workflows. And there's really only a handful of companies that have really taken agents into production, and they have already written a plethora of blog posts about how difficult it is. And really, it comes down to the fact that there is major challenges in just running complex AI agents in containerized environments, especially, but also not in just containerized environments. Because let's be real, the more agents are autonomous, the more ROI they can actually deliver. And the more autonomous they are, the more things can actually go wrong. So you want to make sure that you're prepared to tackle all of these challenges. So how do you run AI agents that can, first of all, communicate natively with each other? Because you're not just going to have one agent, you're going to have multiple agents, and they can communicate using your existing infrastructure. So you don't have to learn a whole new, message broker or additional infrastructure if you don't have to. And how do those agents maintain their state in your own enterprise-grade database? And finally, and that might be actually the most important thing of all, if you have an agent that now is very autonomous and it talks to internal systems and it has 100 steps it's going through and it fails at step 99, how do you make sure that it can actually pick up where it left off and it doesn't need to start all the way from the first step, and you now need to pay for all of those 99 calls, and really lose the entire state. This is a real problem with most agentic frameworks today. They're not stateful and they're not enterprise grade, and this is essentially what Dapr comes to solve. So if we look at Dapr, Dapr, I'm not going to talk about it too much. It has a bunch of APIs for developers that is very general purpose. But what we've found is that some of those Dapr building blocks or APIs are really foundational for AI infrastructure. So workflows, the top left here, is extremely important to make sure that agentic workflows can actually run to completion and that they maintain their durable execution, meaning they maintain their state and they pick up where they left off. And if you're talking about multi-agent collaboration, PubSub is important. If you're talking about letting agents discover other agents in your environment, then you're talking about service discovery. If you want to save the agent state in your database, you're talking about stateful conversations. And then how do you actually make sure that when you're talking to something like Anthropic or OpenAI, that you have PII data obfuscation, meaning you do not send things like credit cards and emails and IP addresses into public LLM providers. And so Dapr actually has the building blocks to support all of that. And really, agentic frameworks today, they focus on specifically abstracting LLMs, tool usage. So they integrate with something like MCP, which exposes tools, which are essentially gateways into internal systems. They focus on roles and responsibilities. So you can define multiple agents, and each one of them has a role in the system and a responsibility they need to adhere to. And they also focus on very basic workflows, which are non stateful, which is a problem. They also try to focus on multi-agent collaboration, which is usually an agent calls an agent synchronously. But then, if one agent fails, then you're in a problem because the calling agent essentially fails the entire workflow. And then there's this concept of ambient agents, which is agents that do not start from a user prompt, but these are agents that are connected to a stream of events, and each event can actually trigger an agentic workflow. So this is the main focus for agentic frameworks, but they're actually missing a lot of really important stuff. In terms of abstraction reasoning, they're missing guardrails around PII. In terms of tool usage, MCP has a lot of criticism going for it around authentication and error handling. It's a very bare bones protocol, essentially built around just HTTP streaming and REST. In terms of roles and responsibilities, you now have a system with multiple agents. That's great. We've spent the last 10, 15 years trying to come up with ways to secure communication between microservices, but now we have to secure agents, decide which agent can talk to what other agent, how do we do authorization. In terms of workflows, as I mentioned before, most agentic frameworks are very, very basic. They will allow you to execute a bunch of steps, but if it fails at any one given point, it'll just start from the beginning. And that can lead to a lot of problems and can become very costly. Multi-agent collaboration, it's important that you are able to communicate securely and reliably so that if one agent goes down, it comes back up. It should pick up on the inbox of messages it has. And a lot of frameworks are just missing that because they don't have that event ingesting layer, like the one that Dapr has. Yeah, and then just all these enterprise capabilities are something that's sorely needed when you're taking agents from your local dev machine and wanting to fire them off into production. And this
Can
is
I,
really,
can I ask
yeah,
you just
of
a
course.
question on that one? If we go back on that slide, I think one thing people don't realize is how important is that authentication, like for the enterprise. People are building agents, but they want to go to production, and they always get on some stage of like authentication is one of them, like encryption. I know that you're going to show on your demo, but just like focus on authentication. Tell me like how is Dapper doing that differently?
Yeah, great question. So authentication comes into play in multiple places. The first, I would say, is agent to agent communication. When one agent calls another agent, you want to have some sort of authentication to be able to authenticate the calling agent to the callee agent. And this is just not built in today, not in A2A or any other type of framework. And this is a real problem. You might have your, Azure AD provider that you want to put before agents call other agents to be able to carry that identity over. With Dapr, you can actually do that. And with Dapr 116, we'll have a complete example that shows how using Dapr, you can inject middleware where when an agent calls another agent through Dapr, Dapr automatically connects to your Auth2 provider inside of your organization and kicks off an authentication workflow that is outside of your code. So your code doesn't have to do any boilerplate in authenticating and connecting it to the actual agent. Dapr does the whole thing automatically for you. Then there is the aspect of MCP. MCP, servers are non-authenticated by default. There is work inside of the protocol done now to basically explain to people how authentication should be done, but there is really no implementation for it. And it's also getting a lot of criticism because every sort of proposal is putting authentication inside of the MCP clients, and that's putting it within the domain of the app. So if the app gets compromised, then the MCP server or client can get compromised as well. With Dapr, however, also coming in 116, you will be able to do authentication versus any MCP server using Dapr. So you can basically have Dapr kick off authentication before any call your agent or just regular application is making into an MCP server. And this is extremely powerful in just making sure that enterprises get these security grade capabilities when they're talking between agents or between their apps and MCP servers.
That's great. That's what I think the enterprise is looking for, and I haven't seen that anywhere. And like you said, that MCP client doing all the authentication is kind of scary, and I like to see that on Dapr agents. Let's
Yeah.
go. Let's see the code. Let's see what you have to show on demo as well.
Okay, yeah, I will just finish off with one thing. So, Dapr can really integrate with existing frameworks. So, if you're using Semantic Kernel, Laudagen, or Langgraph or Crew AI, you can make use of the Dapr APIs to make these frameworks better. But Dapr also has its own agentic framework, which is called Dapr Agents. It is being co-maintained by Diagrid, my company, and NVIDIA. Shout out to Roberto Rodriguez, the original creator of this framework. It's the only vendor neutral open source agentic framework today within the CNCF. It's a sub project in the Dapr organization. And it really enables all of these important things we talked about inside of the framework itself. So it has durability and workflows built in. It has MCP and authentication built in. It has a whole bunch of these things. So we're going to be taking a look at that now. I'm switching over to VS Code, and I trust you can see it. And what we're going to be taking
You
a look
zoom
at,
in a little bit.
yes, is this better?
Yep.
All right, great. It's fairly big for me, but I think I'll do fine. So today we're going to be running something called an agent mesh, which is a collection of agents that are coordinating a task. And we're all going to be firing that locally. So I have Dapr installed already. The only thing you need to do to really run Dapr is just do Dapr init. I already have it installed, so I don't have to do that now. And here we have a bunch of agents, and these agents are essentially representative of the fellowship of the One Ring from Lord of the Rings. So our task for today is to come up with a plan to take the One Ring to Mordor, and we have an elf, which represents Legolas, a hobbit, which represents Frodo, and a wizard, which represents Gandalf, and they're all gonna consult with each other to come up with the best plan to take the ring to Mordor. And so this is extremely simple, right? This is really the only thing you need to do to write a Dapr agent. So this is really important for non-technical people as well. This is essentially code you can copy paste, and you don't really need to change anything except for really just English, right? Like you can give the agent a name. In this case, it's Legolas. We tell it what its role is and a set of instructions. And once you have that, you're basically good to go. These properties essentially connect the agent to the underlying infrastructure. So we said it's important for agents to be durable and to be able to communicate. And this is just boilerplate configuration that connects the agent to their message brokers and state stores. And these can be, for example, if you're running in Azure, it can be Azure Service Bus or Azure Cosmos DB. But really, the crux of the issue is the durable agent here, and it's durable because if the agent goes down or if any one of those agents go down when the workflow is executing, and today our workflow is to take the one ring to mortar, then the agent will pick back up the work where it left off and it'll execute it to completion. So this is the elf service, and here we have the Hobbit one. Looks exactly the same, only the role is different. It's a Hobbit, and it needs to carry the one ring to Mordor. Sorry, to Mount Doom, which is in Mordor, and it has just a different set of instructions, and that's it. So let's just see how we can run those quickly and with workflows built in. As you saw, there was literally zero workflow code here. The developer doesn't need to know anything about Dapr, about workflows, or about any really complex distributed systems challenge. The only thing they need is to define a goal, define a set of instructions, a name for their agent, and just uh, create a new instance of this durable agent. And really, that's all you need. And then the only thing you need to do is start it. And there you go. So let me run this real quick. This is a Dapr CLI command that's going to be running this, all of those agents for me. I really encourage you to go into our repository and get this, quick start and try it out for yourself. So what you're seeing now is a bunch of logs because we are essentially starting the Elf, Hobbit, Wizard, and Workflow LLM services. And this is starting each one of those agents individually. Each one of those agents is now registering as an agent. And we also, as part of this workflow, kicked off the task. So the task was how to take the one ring to Mordor. And as we can see, we're going to wait for this to finish, but we can already see that some of those agents have been given a task. So, for example, this agent was given the task review the marked potential danger zones and offer strategic insights and alternatives to safely navigate from Rivendell. And this is probably for Legolas, the elf. And if we continue further down, then we can see that now it's generating the summary. And if we go into each one of those, you can see that Dapr actually outputs the JSON, these JSON files. So this is actually a fully auditable trace of everything that went on in your agent history. And so this basically has the entire message log for this specific agent with all of the content that it's receiving and the contents that it's sending back. So this is really great to just understand who the agent talked to, when did he talk to, what was the message they were getting, what message they sent back, and really to come up with a plan. So, for example, this is for Gandalf. This is for Frodo specifically. No, so we can see all of those different content. So we have the chat history here. We have the mission briefing. So this is the first task that we received. We have received the following task. How do we get to Mordor? We all need to help. And then it came up with a plan. So begin by examining the maps we were provided with and then chart a course. And then those agents started basically collaborating with one another. Now, this is all great, but you might also be running your own tracing. So as you can see in this code here, I don't have any form of tracing involved. I don't have anything related to something like AWS X-Ray or Azure Monitor or Zipkin or anything else. But if I actually open Zipkin here locally and I run this, we can actually see all of the traces for these different applications. And if I look at dependencies here, we can actually see the workflow app. You can ignore this thing on the left. It's another call, but if we focus on this workflow app here, we can see that it is actually coordinating between the Hobbit app, the Elf app, and the Wizard app. We can see that they're not only coordinating with the application that started the initial prompt, which was how to take the one ring to Mordor, but they're also interacting with each other and with a state store specifically. So this gives you enterprise grade capability, and this is just working with Zipkin, which is what I have installed locally. If you're running in Azure, this will work with Azure Monitor or any other tracing solution you have outside of the box, and you can essentially click on each one of those and see all of the traces. So this gives you enterprise level observability into all of your agentic workflows, which I think is pretty great.
It is amazing. Just seeing that, and how using the Dapr components, the
Yeah,
flexibility of plugging, like you say, Zipkin, you could replace that with anything that you want to get that telemetry. And
correct.
I
And
think, yeah,
yeah,
go ahead, go ahead.
No, so you brought components, and thank you for doing that because I didn't actually show how the agents communicate with your underlying infrastructure, right? So, for example, this is the state store that's being used to save the agent state, and it's using Redis. But for example, if I wanted to use something like DynamoDB, all I would need to do is literally type Cosmos DB and use Azure Cosmos DB to save my state, and this metadata would change to something like URL and the
Yeah.
Cosmos DB master key.
I think the message here in why Dapr Agent was created by Roberto was Roberto used to work for Microsoft and he saw Dapr being so flexible that he could build like AI framework using Dapr. And that's pretty much how Dapr Agent was born. And it was a brilliant idea. And also, we're looking for the community to help. We don't want to be a too long video, but how the community can help now to bring, we have Python ready to go, we have MCP integration done. What's next and how they can, the first thing I would ask is everyone go on the Dapr agents and give a star for the project. It's an amazing project. You're not going to regret that. Give our support, and if you like it, Dapr project itself has so many stars, but the Dapr agent itself, we want your support and how they can help. Tell me.
Yeah, so first of all, yeah, starting the project is definitely good because it increases its exposure to people just surfing on GitHub or the regular internet. And then just visiting, this link here, which I'll give in a sec, and just opening up issues, trying out and contributing code. We have, explanation for why do you want to choose Dapr agents, why they're important. We're essentially going over the initial roadmap, and so we are very transparent with the community about the stuff that's important to us. And as I said, this is being co-maintained by Roberto from NVIDIA now and Diagrid. And we have a bunch of end user companies who are already using Dapr agents who are also contributing to the project. And here we're basically saying what we want to work on next. So if you want to see, something that's important to you, please raise an issue, and we might be able to just put it in the roadmap. And if you actually want to collaborate with us and work with us, that's going to be great. And we can then contact you via Dapr Discord or through email, and we can coordinate joint work. There's nothing we love more than seeing people coming in the project and contributing their time for the benefit of everyone.
Yeah, that's it. We want make sure that you look the video description. We're going to leave some videos that we have done about Dapr itself. If you don't know Dapr, you can watch the other videos. And Yoran also had some videos on the Diagrid, I think, YouTube channel,
Yes.
going deeper. There's even a webinar there that was amazing, by the way.
Thank you.
Very, knowledge there and explaining all the details like durability, scalability, authentication, service discovery of the agents. That's very important. So those points are very enterprise grade, and that's what we want to show today. Thank you a lot, Joran, for Schneider for coming, and Mark as well was here before, but he couldn't stay for the recording. And yeah, it was great to be with the community around agents and that again. Thanks so
Thank you so
much.
much for having me. Thank you.